Sanford Eigenbrode. Dr. Eigenbrode is a professor and the chair of the Division of Entomology at the University of Idaho. He got his master's in natural resources and PhD in entomology, both from Cornell University. Dr. Eigenbrode is a project director of the $20 million NIFA Coordinated Agricultural Project on Regional Approaches to Climate Change, or REACCH, in the Pacific Northwest Agriculture. And he's also a co-PI on two NSF IGERT projects, specifically on studying resilience of ecological and social systems in changing landscapes, which includes extensive collaboration with the Tropical Agricultural Research and Higher Education Center in Costa Rica. And just this year, Dr. Eigenbrode was named University Distinguished Professor at the University of Idaho. So let's all welcome Dr.
Thanks,
Eigenbrode.
and hello, everyone. I'm representing the REACCH project, as Jeffred mentioned, and the goal of this presentation is to help the students in the TCAP project become better informed about what we're doing, and also as part of a hoped-for integration between our project and the TCAP project. Our project is, as you will learn, it's about sustainable wheat production under climate change. And we don't have any breeding component. So all our breeding, all of our efforts to incorporate thinking about variability in the crop and adaptation of the crop to climate change will depend on collaboration. So that's with TCAP breeders, with other breeding programs at our institutions, particularly WSU and UI, and with Lima Grain, which is partnering, as you might know, with University of Idaho to stand up a breeding program here, and Jim Peterson, who's the director of research, is an affiliate of our project. But Aaron Carter at WSU, and to a lesser extent, Mike Pumphrey and John Lee Chen at WSU and UI, respectively, faculty members have been starting the conversations. So I think we'll do this so that students can see what we're doing, and like to get to the point at the end. That's the goal, and if I have to, I'll go fast to reach that point where you as students and I can have a conversation about ways in which you see the opportunities for interaction between the projects. So the four pictures up here, and I'm going to shut myself off now, and you can just follow the slides, are insects to remind me that I'm an entomologist, and my work as an entomologist has led me towards integration, as you heard from the bio. So you can't study the insects in isolation. You must study them in context of their production systems. Shown here are the production systems associated with those four insects I just in the previous slide. And since the 2000 or so, most of my work has been part of large collaborations that incorporate insect biology, but think in terms of the systems. So the REACCH project is no exception. That is, as Jeffrey mentioned, it's a $20 million NIFA-funded project that aims to, we'll get to the goals in a minute, but it's about wheat production in our region. I'm sure, since you're aware of the context in which a lot of your work is taking place, that you understand that climate change is just going to make management of production systems more complicated. This is a well-known quote on that, or one that's well known to us. We use it a lot. This is supposed to be a figure here that shows the front cover of the recent, very recent, February 9th Federal Advisory Committee National Climate Assessment Report that was released for public review. And this, February 9th, was a USDA ARS published volume on climate change and agriculture, which becoming increasingly acceptable information for the public and including our producers that climate change is underway and is certainly beginning to impact, and in some parts of the world, strongly impacting production systems and is inevitably going to impact most production systems. So here's some climate data for our region, the Pacific Northwest. These are models from the CMIP-5, which is the Climate Model Intercomparison Project at the IPCC. This is the latest set of models. These are, for our region, projections for November to April. And this is showing on the left temperature and on the right precipitation from the current condition into the end of the 21st century. And depending on the model, you get different outcomes and a lot of variability, but they're unequivocal in the projection of changing of warmth, increasing temperature, and they're also unequivocal for November, April, not unequivocal, but close to, for increasing precipitation, whereas I don't think I have a figure for you about summertime, but summer will be drier. So some challenges, not as severe as other parts of the world, but eventually substantive changes. This is, if we just go in the center here, almost 4 degrees C increase from ambient and averaged in the, and the similar, it's even stronger in the summer, so it gets to be pretty warm. Oh, there is some summer data. So this is the summer. You can see the tendency towards declining precipitation in the summer months, June, April. I mean, June to April. I shouldn't say June to April. I should say June to November. And this is our domain, and I think it's, some of you are out here in Central Time. I now know because I thought this was at 3 p.m. today, but it's at 1 p.m. And this is our REACCH region, and this is the USDA wheat production, wheat harvest 2007 acreage data. And our project is really got a laboratory. The Pacific Northwest has this unique production system in which wheat is produced across the 3 states. And you can see it from space. Production zones are very different across the region. These are pictures of what it looks like, depending on where you are in the Pacific Northwest of wheat production systems. This figure you can see now is a map of production zones that are based on precipitation and degree day accumulation and to some extent soils. This model was first posed by a group led by Douglas in the early 1990s. And using the climate projections and these criteria for these production zones, with zone 6 in the center here being irrigation, and the green one up to the east being rotational crops with cereals with the wheat in rotation with mostly legumes. If we project this to mid-century, we get a completely different picture in some ways. The irrigation shifts slightly. Zone 5, which is wheat fallow, expands, but a new zone 6, which has more degree days and more winter precipitation, which is shown in purple, covers much of the region. So the notion here is different production zones, something that our producers don't even have experience with. So there's some vulnerabilities. Reduce for the region, reduce summer precipitation, increased episodes of warm weather, which will incorporate heat stress and drought stress. I thought those were indented. Increased demand for water and water shortages in some of our irrigated areas. Increased pest pressure and needs for rapid adaptation by producers. But we also have advantages that may come with climate change, longer growing seasons, The greater winter precipitation, if the timing is correct, it can ameliorate or mitigate some of the summer precip patterns. CO2 fertilization is expected to increase wheat yields and yields of other crops in the region by mid-century and potentially even beyond as warming uh, begins to overwhelm CO2 fertilization and decrease yields. And agriculture, I think we like to say, is inherently autonomous in its adaptation because it's always adapting to climate. That's what farmers have done for millennia, unlike some of our other sectors that may be less flexible. Still, we need the tools to allow them to do it and the assets. So we have 3 land-grant institutions, and we have all these acronyms here, which are related to climate research that is underway in the Northwest. Our agriculture is diverse in the Northwest. There's 300 crops grown out here, but this project is focusing on the cereals, and here's a aerial picture of the Palouse region, which have some interesting characteristics that have long been a challenge for us for sustainability. Shown here is severe soil erosion, the reliance on irrigation, the hilly terrain, and on the right is a picture of somebody growing wheat with no-till, which is well known to many of you perhaps, but it's not as it has not been adopted as much here as it has been elsewhere in the USA. There's been some constraints in the soils and terrain. It's been one of the impediments, but the rest of it's kind of mysterious. So our project is 20 million, so it's almost as big as the TCAP. It's got 4 institutions, 12 academic research units, a safe greater than 40. It's well greater than 40 right now. I think if we count the scientists, students, and postdocs, we're much closer to 80 people involved in the project right now. Our goals are adaptation and mitigation first, and so the research is focused on finding ways to develop and implement sustainable ag practices under existing and projected agroecological zones, and that refers to the map I showed you a moment ago. And mitigation, this is charged by NIFA. They want us to work on reducing nitrous oxide emissions. They're not too bad in the region compared to other parts of the world, but there's room to improve our nitrogen use efficiency, both in terms of the genetics of the crop and how we apply it. And then the last 2 goals are about integration. Well, they're about the other missions of the land-grant institutions, really. Participation, so working closely as we can with stakeholders, that is the farmers, and also the NGOs, people who are interested in climate and climate impacts on our region that aren't necessarily farmers. So we have a stakeholder advisory committee of farmers and ag industry representatives who have helped us develop the project from the beginning and look over our shoulders, or are invited to look over our shoulders at our annual meetings and through our website and other venues and give us feedback and continue working with us. And education, increase the number of scientists and educators. So we have a lot of students. I don't know how many you have, and we can talk about it in TCAP, but we now have close to 30 students and several postdocs, 5 postdocs in the project. But we also have a K through 12 component where we're working with a little bit with elementary and much more with high school educators in the region. This is a tough one, but I put it up because this is a webinar, and maybe you can review this sometime if you're interested. But essentially, this is showing how the whole project is conceived. So we have this production zone. I don't know if you can see my little, if you view my screen, you might be able to see that I have a pointer here. At any rate, on the top left is a map of current conditions, and on top right is a map of projected conditions. Lower left is a map of the current production zones based on the NASS
We
cropland
can't
data
we
layer,
can't
and the lower
see the pointer.
right map shows a made-up
We can't see the
cropping
pointer.
system, array of cropping systems that we are planning and attempting to provide the science to support that would be adapted to the coming changing climate. So the way we're doing it, we've got all these things in the green arrows, modeling, working heavily, strongly to interdisciplinary, so the entomologists and the sociologists, the weed scientists, the agronomists are all working as closely as we can together. We are doing monitoring of water, carbon, nitrogen, greenhouse gas emissions as baselining to understand how our treatments would be influential regionally. This thing, dynamic AEZ, which is the next one down in the green arrow, in the green box. Hey, could somebody tell me if you can see the pointer? This is a test. You can? Oh, so dynamic AEZs, agroecological zones. We're taking an approach I'll describe to mapping these more precisely. We have long-term experiments looking at alternative production practices. We're monitoring and modeling biotic factors, insects, pathogens, weeds, earthworms, and we are involved with the socioeconomic dimension, so social, world sociology and agricultural economics. And then another section here is about our education. This is the K through 12 curriculum development and our graduate and undergraduate students, I already mentioned. We have an extension component of the stakeholders I mentioned before, and we just hired 3 days ago our extension faculty member who will be 100% devoted to the project and communicated to the stakeholders. And cyber infrastructure, we're generating a lot of data, as you are, and we're managing it. So those are the activities. Outputs, I just don't think I should spend too much more time on the slide, but these are the outputs we expect from those inputs. And then the goal is increase soil organic carbon, decrease greenhouse gas emissions. I'm on the right side, increasing nitrogen, water, and energy efficiency in the system, improving tillage, residue management practices, and increased cropping diversification and utilization decision support tools. We're also thinking that the project's a 5-year project like yours, and we're preparing for the longer haul. As we do this project, we are setting up an infrastructure and a network for collaboration that we think will outlive the project, and we're planning for that. And that's this arrow down here. So we have 8 objectives, and here I think we can come back to these objectives easily. They are reflected in the figure I just showed you. And rather, we can come back to these since it's easy to do in Adobe Connect. And I want to leave time for discussion. So the first 5 goals are about research, and they pertain to some of the points I raised in the previous slide. And the next 3 goals are about education, extension, and capacity building, including the cyber infrastructure that I mentioned. So just a little bit about what we're doing on each of these things to give you an overview. We have economists located at Oregon State University who have an economic modeling approach that is regional in scale to understand the drivers necessary for adoption of alternative production practices, both market-driven and potentially policy-driven. And that model couples with a widely used cropping systems model called CropSys, I'll describe a little bit later, and a climate model, or a suite of climate models And each of these is represented by people in the project. So we have 3 atmospheric and climate scientists. We have a number of agronomists, and we have Claudio Stockel, who is doing the cropping systems modeling and economic modeling from the Oregon team. And this is an example of what our climate models look like, because we're really interested in getting down to finer scale models that will allow us to project finer scale climatic conditions into the future. Because if you look down at if you look at the National Ag Statistics Service cropland data layer for our region, it's pretty finely divided in different kinds of practices across the region. There's lines in precipitation and lines in degree days, and there's terrain. So it's very heterogeneous, and our future will be heterogeneous too. So this is multivariate adaptive constructed analogs that John Abatzoglu, who's turned into our most productive climate scientist in the project, is working on, where raw global circulation model data are compared with historical sets of observation data on climate to match up historical GCM kind of hindcasting with historical fine-scaled mapping, then construct the analog and use that for projections so that you can have downscaled data and zoom in on the landscape and look at climatic characteristics out to the end of the 21st century. So an example, here's the western US. And this is output. Note the date here is 2045. It's not a prediction of things that will happen in 2045, but it is a projection of the types of patterns expected. This is maximum temperature, accumulated precipitation, and short and downward shortwave flux, which is a result of cloud cover. And as we page through this, I'm going to page through a few days of this model. And the model does this. So what we're seeing here, and I can go back a second and do it again. What we're seeing is a front, a hypothetical front moving across the Pacific Northwest in 2045 that is driven by inputs from these downscaled models. So these kind of modeling data are underpinning the work we're doing, that at least the modeling components of our work in the project. What have I got there? 4 days. So CropSys is the modeling platform we're using. I'm putting up a webinar. Hold on. Sorry, I forgot that someone was going to pick up the van key. So this is a diagrammatic for CropSys, which is one of the most widely used cropping system models you may be familiar with. And it's Claudio Stockel developed it more than 20 years ago and continues to improve it. And all this input can output a simulated crop. You can get biomass and yield and changes in soil carbon, greenhouse gas emissions, water, nitrogen, carbon balance out of this model. So this allows us to do what would otherwise be impossible, which is to project conditions, project yields under the climates we anticipate in the region, under a set of assumptions which we can drive into the model. So that's the modeling framework, and we're still working on it because integrating CropSys with economic models and climate models is a frontier. So we're pleased with the way it's going, but it takes a bit to do it. Another approach here is this is the dynamic agroecological zones. This is another map of our region. This doesn't show the state lines, it's a little harder to see it, but this is based on the cropland data layer, and you can see different kinds of cropping systems. Each one of these, though, has wheat in them. So this is the irrigated wheat. Here's the grain fallow again, or the wheat fallows. This is continuous wheat, and the blue is rotating with different rotational crops like the legumes and canola. That's possible under that climate. So if we zoom down on this, and which is something we can do, we can generate this layer from the cropland data layer and then use some statistical methods to infer what is the cropping system at a finer scale. So this is Pendleton, Oregon, and these are pixels at, I think these are, I think this is 800 meters, and different cropping systems. So there's a lot of grain fallow right around Pendleton, but if you go just a little bit to the north and west, you get into annual crop fallow transition. And there's even this tongue of annual cropping with rotational crops possible north here through Dayton and Walla Walla. So we can see this, but we can see it on a finer scale than heretofore. And this is another one around Moscow, and there's Pullman for those of you who are coming in for Pullman. So what we can do with this now is use this to track, for one thing, the changes in cropping systems over time. We can also use it to guide our design of our experiments, design our surveys of producers, design our surveys of insects, pests, weeds, and also to ultimately make some projections of what this might look like under changed conditions. We're also conducting experiments. These are designed to be distributed across the region that look at different things. There are 11 locations and 15 experiments. These are the locations across the top, and they cover the region. And these are the kinds of things we're looking at each location: site-specific nitrogen management, crop intensification, diversification, residue management, crop rotation, nitrogen cycling and management, tillage practices, and fertility alternatives. And those are positioned on the landscape as shown here, so that we're doing the experiments that we think are most appropriate for the projected challenges and opportunities in each of these climatic zones. And these are underway, and most of them weren't established, though, until last year. We're also monitoring the greenhouse gases, and we're using two methods. One is what's called an eddy flux tower, which I can describe in Q&A if there's interest in that, which has a large footprint of sensitivity, several hundred meter radius around this tower, and we can measure the efflux of and the influx of CO2 and nitrous oxide and other gases, if we have the sensors for it, from the surrounding crop. And we can place these in different production zones to look at how they are, how the greenhouse gas emissions are changing. And these run continuously around the year, and we're just getting data from the antenna all the time from these production systems at a few hertz. So it's a huge amount of information that is then digested and lets us monitor conditions. And then the other method is to put out the chambers like these that are shown. This is an array of chambers across some different treatments. And each one of these chambers is measuring CO2 and nitrous oxide emissions. And this is a mobile setup that we can move around to different experiments to take measurements over appropriate lengths of time. I'm an entomologist. It seems so long ago since I started this talk, but just to remind you, and we also have pests, we have weeds and pathogens, and we're sampling the whole region. These are the sample sites where students and technicians are getting our baseline and also looking at how these things respond to the existing template of climate that exists across the region. And no, I'm not going to share any more data except that it's coming in and it's quite interesting, and we've found some new stuff. For example, we found an aphid species that's basically exploding through this region that wasn't here before, and its occurrence here may not be um, unrelated to changing climates. We also are modeling, and this is one snapshot of a model for biological control of this insect. It's the cereal leaf beetle. We've plotted here the potential for biological control by this insect, which attacks the larvae. That's what it's doing here. And it's been a pest of wheat. It is all over the USA. It's been out here for about 20 years, if you go all the way out to Montana. And the coloring on this map is showing you the changes in the overlap days between this beetle and this parasitoid by mid-century. And essentially, it's mostly unchanged in a lot of the area. You see number of days of overlap is not changed, but there are some places where it is increasing, which is positive and suggests that the insect would be less of a problem by this date. And there are other places in the red where that overlap is decreasing and where we would project that biocontrol would not be as effective then as it is today. This is one example. We're doing this with a number of different systems. We're also keeping track of our producers. This map shows the producers that we are visiting every year for extensive longitudinal surveys or on their enterprise budgets, and keep track of their expenditures and also their approaches to dealing with whatever kinds of things the climate is throwing them, equipment purchases, modifications of their operations. And this is also a baseline that we're setting up to track. Obviously, the information from this also can inform more aggregated economic models about that will help us understand grower behavior. But we're also doing social surveys because growers behave in a variety of ways that are not necessarily predicted by economics alone. So we have a survey that's just come in of 3,000 producers across the region where we asked a range of questions about their views on climate change, about their plans for adaptation, about their concerns about the particular elements of their systems, so that we can make sure that what we do is tuned to producers' points of view. We're developing an e-extension community of practice that will allow us to collaborate with others working on climate change in agriculture, such as the Sustainable Corn CAP, which is located out of Iowa State University. Some of you may be from there, I don't know. We have given more than 100 grower-focused talks and field days, and we have the Stakeholder Advisory Committee, as I mentioned. And we have here's some pictures of some of our field days and activities we do with producers and other stakeholders to show off the work and to try to educate them. This picture also includes some of our undergraduates who are joining us on their 9-week internships with us last year. That segues to the education. We have the K through 12 teacher surveys analyzed. We're doing teacher workshops every summer where we bring in high school teachers and show them what project's about and provide them with ideas for things they can do in their classrooms. We have a research experience for undergraduates. And we have, this is getting out of date again, we have just a couple more graduate students arrived. So as I mentioned, this total 28 here is now about 30. And we work with the students. These are the students as they were last September, and we have a retreat for them each year where they work together. And the reason for doing that is that, as you can tell from the scope of this project, it's very broad. And there are students here, and Sarah is working on she's got the flux towers going, measuring greenhouse gas emissions. Iqbal is working on plant pathology. This person is working on economics. Adam is doing assessment of the project, and so on. So we're all over the place, and we want them to spend time together and think of ways that they can integrate what they're doing with one another's work. So we ask them to do little projects, mostly related to extension and education, where they combine their expertise to produce something. And some more shots from the retreat. And we'll be doing these every year. The last slide's getting close to the end and into the Q&A part. Cyber infrastructure. This schematic is showing you that what we're doing is handling our own data. We have a full-time data manager, a full-time programmer, and a server to contain all the data of the various types I've just briefly mentioned, to allow us to store it, integrate it, map it, synthesize it, and share it, both within our team and across other teams that might be doing the same kind of research, same kind of large-scale project. So we also have a website, as do you. It's reachpna.org is the way to get there, where one can learn more about the project, see the minutes, and see our annual report and our annual meeting minutes, read about our refresh on our goals. And this isn't a live site, but here you can go into the different objective teams and read what they are working on, see what's new in the project, and so on, part of our communication. And we've done a lot of things in the first year that we are proud of. The sampling I described and the experiments are already providing information producers are interested in, as are the longitudinal farm enterprise budget surveys. We are making those projections. The models are informing priorities in the research that should be done on crop protection.
So, talking about the data, Dr. Eigenbrode, are they
already
publicly
because
available? Like, if
the
you just go
program
to
months, it's
your
ongoing.
website, and if you want to
And
look into like climate
I
data
think
and
we're
stuff, is it
contributing
publicly
to the
available? You could
long-term
download it, or you have to.
establishment of a regional project here that'll outlast our project. So this last statement is that we think we are providing a part of the foundation for a long-term regional integrated research education
Okay.
and outreach project. That's why I'm doing it, and it turns out that is why just about every scientist and most of our participants are doing the work, because we're strongly motivated to be part of the solution towards impending challenges for production systems. And to do that, we're partnering all over the place. And a number of our partners are mentioned here, including the IGERT projects that Jayford mentioned earlier today, the Long-Term Ecological Research Site Network, the Northwest Knowledge Network at the University of Idaho. Here you guys are down here, TCAP, and these are all NIFA-funded projects here, ARS affiliations that we are cultivating. And the breeders, but you'll notice I didn't say much about breeding, and that is the problem. We are currently conducting all our research, and everything that we're doing is built on the assumption that our varieties will be similar. And I know you guys are working on varieties that are not similar for very good reasons.
Okay,
so
that's good. Thank you.
That's a place where the project and all could gain. We are about people and integration. Who needs that? And so I wanted to stop now. I want to go to some prompts I had, I guess, for questions, but maybe before going to that, before steering that conversation that way, I'll just open the floor for any questions, or if anybody who's on board would like to ask, so we can have a little discussion for the rest of the hour. Good question. And right now, the data are not
if
publicly
you could read
available
the
on the
chat box,
website.
Junli Zhang
Because
has a couple of questions.
The data portal is password protected because we have a data management protocol that we want to make sure we're protecting our researchers from premature exposure of their data. So we do have a staged process. On the other hand, if your questions are about access to the climate model data, not through the website, but certainly through me, we can make that available. So if, for example, and this is a very good question because it leads to a potential interfaces. Can these projections be used to help inform appropriate greening activities, targets regarding the kinds of regarding the conditions that future varieties will be grown in? And we're happy to say that those data are up, ready to go, and we can provide them to you. You can also provide it depending on the way you want it. I mean, there can be maps like the ones we showed you, or you can also make a query and we can try to respond saying, I'm interested in this part of the Northwest and the climate projections for that particular geographic region, and we can provide something like that. In addition, John Abatsoglu, who I mentioned, has run these models, because once you do it, you can do it at a larger scale. So those of you who are coming in from other parts of the country, climate models from John's program are available too. So if they're also available for Midwestern and Southeastern and Northeastern regions. So if it becomes interesting to any of you, or you're your programs, your major professors, whatever, to think about the environments you may be breeding for. This is one tool that could help you. Right, so Junli is asking, how come it doesn't include southeastern Idaho? And I'm just going to go up show again. Right. Uh, so what we decided to do, and it could be argued that it was a bad decision, but because you can see this very clean patch here where there's a particular kind of production system predominating, mostly rain-fed, except for the right in the middle where there's some irrigation. Once you get into irrigation out here, other crops can be so much more profitable that wheat becomes a minor part of the system. So it's mostly rain-fed. So that's the kind of tried to not make it too complicated for ourselves by having a multiple system. So down here, where Junli is talking about, um, uh, the most of this is not all, but a lot of this is irrigated. Now, in the future, when I talk about a REACCH for beyond REACCH, so 3 years from now, the REACCH project will be over. First, I hope a lot of what we're doing is relevant where in other places where wheat are grown. And second, the Beyond REACCH project I envision as being all this area. We really do need to and should involve southern Idaho and some of the other, although you can hardly see any wheat, there's some wheat in other parts of Oregon that are not included in the project. So doesn't, that's the reason. We hope it will. Any other chat questions or microphone questions? Okay. Well, do chime in with anything, anytime. But here's some things that could work. And some of this we've already touched on. That the breeding goals.
Yeah, there's a comment
Just
came that we are using we're measuring spectral reflectance. So yeah, that's my next question because I'm also working in drought and heat, and we're kind of measuring phenotypes on a plot basis. So I don't know if you have I don't know your facilities or your equipment if you could do to that level in terms of measuring spectral reflectance and a plot level.
But if there is interest, we can test lines for other things besides what you may be focusing on. That could be one way or another
yeah.
moving through the germplasm or actually linked to traits you may be working on. So for example, we are going to work with some of Aaron Carter's lines just as an exploratory project that represent different drought tolerance, and then examine how those how aphids and cereal leaf beetle react to those lines under different drought regimes in a greenhouse study. Looking for an
I'm working with Dr.
The
Mike
best
Pumphrey.
questions may be better generated
Yeah.
by the breeders than by us, or at least in partnership and conversation. We've already been talking a little bit with some in TCAP about remote sensing. We're using remote sensing at the tower sites. We are installing remote photosensitive uh, photosensors that can monitor crop
Yeah. Also,
conditions.
do you about
And
for there's another
there's
question
interest,
that
and maybe some of you are applying this
elaborate to
technology and can talk about it
ask
today.
would they
We're
be willing to
using
give a
these
seminar on choices like just
sensors
spectral
as
reflectance
a
or
way of
those
gauging
kinds
phenotype
or modeling or something
during
those
screening
scientists in your
for
group?
advanced lines or whatever you're doing. Um, so that's a partnership that we're trying to do right now. We're having a conversation within the next few days between the remote sensing
Okay.
folks on REACH and
Yeah, because
learning
now
how
we
to live
are,
like
I
a
know
country.
in TCAP,
And
a number of students are using
anyway,
JAS and crab
if you're
scan
interested in that
to measure
conversation,
spectral reflectance,
it's
but
just going to be
obviously we're
a phone
some are still having
call,
issues.
but
So yeah,
let
if
me
your
know
group could also suggest
who
other
that,
tools or equipment to measure
that you
the same thing,
connected.
it would be really good.
And maybe another thing that students, I don't really know. I've known a lot of plant breeders. In fact, I had plant breeders on my graduate committee, and I've collaborated with plant breeders, but I don't really know these days how many of you are, what your work is like, how close you are to industry, to the production systems that you're breeding for, and something we can do is then maybe help with that part. So those are 4 ideas, and I have another slide, but any comments on these or additions or thoughts? Yeah. Yes, there's a tremendous amount of interest in this.
Okay, that'll be
Decagon
good.
is,
So
uh, I'm sorry, Jayford, are you right over in Pullman? So
are there any more
Decagon
questions or
is
clarifications?
our local company involved in sensor development, and
Okay.
Lee Bierling, who's working with David Brown's project on on sensor there and sensor based technology is part of the discussion and is part of the REACH project indirectly. And Troy Magny is his graduate student. So if you don't know those people, they are working on this, and would enjoy having you part of that conversation. Who do you work with, Jayfred? Okay, so he's definitely been on the doodle poll that's just been going the last 2 days on finding a time for this conversation. So yes, that's great, and I think so. Obviously, we can learn from you guys on that, and I hope vice versa. Given a seminar on choices of, I'm sorry, don't understand the question yet. How about eLibrary 2 type of clarification? See, well, I wanted to make a general offer at the end of this talk because this was obviously pretty fast and high altitude. I just thought it was appropriate to give you a snapshot of the project as a whole. But follow-up seminars, webinars like this on a topic within REACH that is interesting to you, either something you picked up in this talk or something else, we can and would like to do. So, for example, the question about seminar on methodology for measuring spectral reflectance. I think Troy Magny and Lee Veerling and others who are associated would be very happy. Troy, who's the graduate student I mentioned, has already done that, given us a seminar on his
Is
work
it?
on that.
I don't remember if you
spectral
put it in your
reflectance
first
work
slides, but you could
underway.
I could email them. I could
So
post
I
them
think
also.
he's got one in the can. So
So they
that
can
might be
contact
one
me.
way to go.
Oh yeah.
To ask him, and I'm writing it down.
Yeah. Okay. So there's a
If anybody's
question from
interested in
David
that.
Chappell.
Not
Is
surprising.
REACH present
And I'll
outside
be
the
trying to
Pacific
be at
Northwest in
that
other regions as
phone
well?
conference amongst all those who are talking about the reflectance technology, and I'll mention your interest there too. Great. That's a good interface. I like it. It's getting late, but I'm going to try to go to the next slide because I forget what's on it. But it's oh, so what we're happy